Hi everyone. Today we're going to be doing a practice problem and we're going to be talking about significant figures. This is a concept in chemistry. It's also used in physics and other courses, and it tends to be very confusing just because there are a lot of rules that you have to keep track of. So we're going to do some practice in the context of an addition and division equation. So it's going to combine a few different functions so we can see this in practice in several different steps. Now, my advice for significant figures is that you track those significant figures at every single step so that you don't get confused. What I recommend that you don't do is don't plug everything into a calculator and then try to figure out your significant figures at the end. It's going to be very confusing and you're likely going to get the wrong answer. So let's start out with this problem. Now, the way that I like to think about significant figures when I'm doing a problem is kind of like a March Madness bracket where you have two teams who are competing against each other. One of them wins and then moves on to the next round. That's how I like to think about the significant figures. So we're going to start in the parentheses and then you'll see what I mean by that bracket when we start to go through this. So the first thing in the parentheses is this addition problem on the left. And we have 8.62 plus 4.3. With addition, the rule is that you want to go by the least amount of significant decimal places. So in this case, we have 2 decimal places here, and we have 1 decimal place here. So in this case, the 1 decimal place is going to win out since it's the least, and we get an answer when we add these of 12.92. Okay, and I'm going to go ahead and underline where my significant digit should be because I know that I'm limited to 1 decimal place because of that 1 decimal place in the previous function. So I'm going to underline it and track it throughout because I don't need to round it yet because I'm not at the end, but I'm going to track it using the underline method. Okay, so I'm going to do the same thing with this function on the right. So I have 22.582 minus 6.11. Here we have 3 significant decimal places, and here we have 2. So the 2 is going to win, and when I do the subtraction, I'm going to get 16.472, and I know I'm limited to 2 decimal places, so I'm going to go ahead and underline that 7 because it's my second decimal place. Okay, so now I've done the functions that are inside of the parentheses, and I'm going to move on to my next step, which is to take these 2 numbers and divide them. So I'm going to take 12.92 and divide it by 16.472. The rule for division, now that we moved on to division, we're at a different rule for significant figures. The rule is that you are going to be limited to your least amount of significant digits. So not decimal places anymore, now we're on digits. And I have 3 significant digits on the left, and then on the right I have 4. So now I'm taking a look at these next 2 digits that are competing, and I see that 3 is less than 4, so 3 is going to win in this round, and that is what is going to be my final answer. So my final answer is going to contain 3 significant digits after I do this division. So I'm going to do this division, and I'm going to get an answer of about 0.78436. It repeats a little bit. Or not repeats, but it keeps going a little bit. And I'm going to underline my third digit because I know I have 3 significant digits. But lastly, since this is my final step and I'm trying to get a final answer, I'm going to round it this time because I want to make sure that my final answer has only 3 significant digits and that it's completely rounded. So before I round, I'm going to take a look at the digit after the significant digit that I'm rounding to, and I can see that it's a 3, which means I'm going to round down. So my final answer is 0.784. Because those 3 significant digits won out that round, and I'm going to have 3 in my final answer. And that's how you would track your sig figs during a math problem. If you have any questions about this, please feel free to leave a message in the comments. Thanks, everyone.